Let's start by talking about changes of coordinates for integrals in 2D. To do a change of coordinates, we have to have two new variables, u and v, and we want to express our x and y variables in terms of them. So x and y are functions of u and v. Then the change of coordinates formula says that if I have an integral of some function in x and y coordinates, to convert it into new coordinates, u and v, I replace x and y with what their expression is in terms of u and v. And I multiply by this area distortion factor. It's a so-called Jacobian determinant. I write down all the derivatives of x and y with respect to all the inputs u and v, the same way as we calculated this Jacobian matrix before. It's going to be square. I take its determinant, and then I take the absolute value. And the other thing I have to do is I have to re-express my region. So that's a lot to take in. Let's talk a little bit about what we actually do step by step when we're doing change of coordinates. The first thing is we have to re-express x and y in terms of our two new variables, u and v. So for example, in polar coordinates, we had x as r cos theta and y as r sine theta. Then we have to say, let's look at our region and write what are the boundaries for this region in terms of our new variables, u and v, by contrast with our old variables, x and y. And then we calculate the area distortion factor. We write down this Jacobian matrix, we take its determinant to get a Jacobian determinant, and then we take its absolute value. That's the area distortion factor. We want to multiply by that to compensate for the area distortion so that our answer is going to be correct at the end of the day. So here's an example. We want to calculate the double integral of x times y with respect to area over a region 1 less than or equal to x plus y less than or equal to 3, 0 less than or equal to y minus x less than or equal to 4, using a particular coordinate change that I've discussed in the last lecture that changes diagonal lines into nice coordinate lines. So here's a picture of this region up top. It looks unpleasant from the point of view of doing double integrals before, because we have to kind of cut this region into 4 separate pieces because there are 4 points where the upper and lower bounds or sorry, we'd have to cut it in 3 pieces because there are a couple of points where the upper and lower bounds change their nature. But let's figure out how to do this substitution. So we've already got x is u plus v and y is u minus v. So that's step 1. We know how to express our old coordinates in terms of our new ones. The second is we want to figure out what happens to these limits of integration. It used to be 1 is less than or equal to x plus y is less than or equal to 3, but let's substitute in x is u plus v and y is u minus v. That goes between 1 is less than or equal to between 1 and 3. That, if we simplify it, it says that 1 is less than or equal to 2, u is less than or equal to 3, or u is between 1/2 and 3/2. Similarly, the region 0 is less than or equal to y minus x less than or equal to 4. If we plug in y as u minus v minus x, which is u plus v, that turns into 0 is less than or equal to minus 2v is less than or equal to 4. So v has to be greater than or equal to minus 2 and less than or equal to 0. So this change of coordinates turned this ugly region into a nice rectangle where our u coordinate goes between 1/2 and 3/2, and our v coordinate goes between 0 and minus 2. Now, what's left is to calculate this Jacobian determinant. So we write down on our top row, we write the derivative of x with respect to u and v. So the top is the derivative of x with respect to u, the derivative of x with respect to v. So those are 1 and 1. Our bottom is our derivative of y with respect to u and our derivative of y with respect to v. So we're going to take the determinant and then we're going to take the absolute value of it. The determinant of this is -1 minus 1 is -2. And so the area distortion factor is 2. So what we do is we take this double integral of x, y with respect to area, and we turn it into the double integral of x, which is u plus v, times y, which is u minus v. We throw in our area distortion factor, which is 2, and then we set up the bounds of integral du dv. U goes between 1/2 and 3/2. V goes between -2 and 0. So it turns it into this integral. And by contrast with the original integral where the bounds were really unpleasant, this integral is doable. We can just run through it stage by stage. We don't have to break it up into pieces. And so this change of coordinates, even though it takes some work to set up the Jacobian and set up the new limits of integration, we do get a net savings as opposed to calculating 3 double integrals.